still after so many hours, and we still have a few more hours to go. What I'm going to do now is announce what we have coming up in the next half hour. We have two parallel sessions. One is Christoph Jos from Lincoln Electric, Italy, and he's going to be talking about learning to leverage short PDCA cycles. And it's going to be moderated by Roberto Ronzani. The second parallel session is The Secret to a Successful Project by our friends in Slovakia, Jakub Votava, moderated by Veronika Gregorkova. And here on the main stage, I'm welcoming my friends from Germany, Prof Roser, Professor of Production Management at the Karlsruhe University of Applied Sciences, and Jochen Roser, I think I'm pronouncing it correctly.
That's correct. Yeah.
But I'm not too sure. Yeah, there you go. Good morning. And Christoph is going to be taking us on a grand tour of German automotive. He's been visiting, I believe it's 15 car plants in the past few months. And so he's best placed to give us the lowdown of what's going on in the automotive industry in Germany. So guys, you have half an hour and I will see you very soon. Have a great session and thank you for being with us.
Okay, so hello everybody at the presentation of the Grand Tour of German Automotive. As you know, if you've got any questions, answer it in the question and answer session, and we'll try to deal it later on at the end of the session. And for now, give me a few seconds to introduce Chris before we start the presentation. Chris is a professor of production management at the University of Karlsruhe, and you could truly say he's a lean expert in all fields of you can imagine. So he's been starting his lean career at Toyota, for 5 years doing lean development. After this, he was at McKinsey for another 3 years doing lean consulting projects in over 200 companies. And after that, he was 5 years at Bosch in the development of lean trainings. And so for 10 years now, pretty much, he's now in the University of Karlsruhe in the field of production management. And he's the owner of the All About Lean company with a huge blog with over 500 articles on really literally any topic in lean production, which you could imagine. So maybe some of you know that blog, and all the others, it's definitely worth a look inside. You will find any question answered in that blog pretty much. And needless to say, he's the author of many lean books and even more to come. So all in all, you could truly say we have now a real lean expert on the stage. And if you're stuck in any way in your company with any tricky lean problem, I think Chris would be the #1 address to ask for advice. So enough for now with a warm welcome. Welcome you, Chris, on the stage, and the stage is yours now.
Thank you very much. Just not sure, can you see my screen?
I can see the screen.
Wonderful. So, as Jochen said, this year I did a grand tour of German automotive and visited a whole lot of different car plants, altogether 16 different car plants all over Germany, with all major car makers included. There's, of course, a couple of plants in Volkswagen, Emden, Wolfsburg, Osnabrück, and Dresden. We have Mercedes-Benz with Bremen, Rastatt, and Sindelfingen, and also the now Daimler Truck in Wörth. We have Audi in Neckarsulm and Ingolstadt. We have BMW in Munich and Leipzig, and we have Porsche also in Leipzig and Zuffenhausen, and also the bicycle plant of BMW in Berlin. So pretty much of all the German automotive industry, I've seen more than half of all final assembly plants. Focus was on final assembly because that's a more interesting part. And this allowed me both a qualitative and quantitative comparison of those plants and seeing how they differ. And it's a continuation from 2017, where I did a grand tour of Japanese automotive and did pretty much the same thing in Japan, seeing 20 plus Japanese car makers, all 7 major Japanese brands, and also doing a qualitative and quantitative comparison. And I won't go into every single plant, we don't have the time for that, but I pick out a few plants which stand out in one way or another And I will go into quite a bit of detail of how they compare in terms of performance. But just as a beginning, let's start with the most beautiful plant. And that one was the BMW plant in Leipzig. Most beautiful plant, closely followed by the Porsche plant also in Leipzig and in Zuffenhausen. But I think BMW Leipzig, most beautiful one. It's designed by Zaha Hadid, the famous architect, and it has a very stunning central building. On the left picture, you see the central building, the office, which connects the entire plant. And not only is it an office, it's also part of the material flow, because on the right side, you see the big open office spaces. And in typical Zaha Hadid style, so there is rarely a 90-degree angle. It's all some kind of odd angles. And what I found most interesting, the assembly line or the production line goes through the office building. If you look here on the left, you see kind of a line, and on the right, it comes back. So that's actually the assembly line from welding to painting, and or a kind of the buffer actually from welding to painting, and from painting then to final assembly. It goes both times through this office. And since they're working on different shifts, kind of if at the beginning of the day the line is full, and at the end of the day it's emptier, because you have a 2-shift and a 3-shift operation in different parts of the plant. And it's, for me as an engineer, it's just nice to see how the product goes through the plant. Besides BMW's being not the ugliest product in the world, it's actually nice to see. And they did some cool lighting with that too. But BMW was not only the most beautiful plant, it was also the most efficient one. Because what I did in every single plant, I tried to estimate how good or bad are they. I tried to estimate the percentage of value adding time. I love to do this in all kinds of plants, just by counting people and seeing, when I observe them, are they adding value or are they not adding value? Waiting, transport, talking, movement, that kind of stuff. And I estimated a percentage value adding time. And the Leipzig plant was the most efficient plant in Germany. Not in the world. Toyota is better, but BMW is pretty darn good. And this one here is an aerial view of the BMW plant. And here, that is the central building from Zaha Hadid. Again, even the parking lot doesn't really have right angles, but here's the central building. Behind is the press shop. Here are the 2 paint shops. And in here is the final assembly line. And around it, a little bit of logistics. And the final assembly line, if you look at it closely, it looks a little bit like an odd-shaped building. It has here those kind of fingers sticking out. And that is intentional. That is a system they like very much, and which I also thought is very nice. The finger line layout. That is the same building in a diagram, and the assembly line comes in here and then goes in those fingers, kind of zigzagging in and out, and until eventually it comes back out at the end. And those finger lines is a special design to give them more capacity, to allow them to extend the line. Because if you build a plant, it's good for what you're doing now. But 5 years, 10 years, 15 years down the line, it may look very different. You may make different products, you may have different machines, different models, and you may need more space or less space. And this building is designed that you can extend those fingers. Each of those fingers can be made longer if there's a need for additional segments of the assembly line. And if you look closely, the aerial picture has 1, 2, 3, 4 fingers, and 1 finger here, it's missing, because the aerial picture is, I think, from 2005. And since then, they started a little stub finger here and made those longer. Also, there's a direct connection to the logistics, a bridge here. That's that one. And now they have a second bridge here, so it's easy to access. You can drive the truck almost all the way in between the lines, so it's easy to get the material to the line with this gap between the fingers for logistics and transport. So I thought it's a very cool concept, and I didn't see this anywhere else in the world, but I thought it's a very cool approach in keeping the line flexible even over longer periods of time. So you can make the line longer, and not just longer at the end, but also in the middle, because some more tricky machines are kind of hard to move. So you don't want to move the big machines, but with this single line layout, you can still fit fit additional line in between. So not only the most beautiful, but also the most efficient plant. The second most efficient plant I found in Germany was also BMW. This time it was Munich. Very different plant, because the Munich plant was founded in 1922, when Munich was a lot smaller. Since then, Munich has grown, and now, as you see in the current picture, in the aerial view, or TV tower view to be precise, it's in the middle of the city. And that makes it a lot more difficult to expand, and they are forced to work on multiple levels on top of each other, because they simply don't have the space around it anymore. What I liked here particularly was their paint shop. It's one of the few plants in where you can see the paint shop as part of their tour. And with paint shops, the challenge is always the changeover, because you have to clean out the old paint and put in the new paint, and that is a lot of waste. And in the old style, they had to clean the entire tubes, and it was very wasteful. Now they switched to cartridges, containers. So every paint robot has 2 cartridges, one he's using, and the other one which is prepared for the next one. So when they do a different paint color, they just switch the cartridges, which goes much easier and faster than if you have to clean the entire tubes. And they have quite impressive 180 different paint color options for their cars. Well, of course, if money is no objection, you can have pretty much any color, but they have 180 colors as part of their regular paint selection, which is quite impressive. So also very impressive plant. I said I compare all plants, and this one is the percentage of value adding time. What percent of the time are the operators actually adding value to the car, assembling something, instead of walking around, transporting, waiting, talking, and all those other kinds of ways, which you all know already. And clearly, BMW Munich and BMW Leipzig are top-notch. Very, very good plants. On comparisons, they're kind of on a similar performance level as the Toyota plants in Japan. Then BMW plant in Berlin, which makes motorbikes, not so much. That was, to be honest, a bit chaotic. But the Munich and Leipzig plants, very, very good. Not bad either was the Porsche Zuffenhausen Taycan line, which is their newest line. It's like now 4 years old, so a very, very new line. The Leipzig line was 20 years old, and the Zuffenhausen 911 line is 40 years old. And you see kind of the oldest line is also the least performing one out of those Porsche lines. But overall, very interesting comparison. And yeah, as I said before, Munich and Leipzig BMW really sticks out. At the very end here, you see Dresden, the Volkswagen plant in Dresden, but I'll talk more about this in a bit, because that is kind of a special situation. That is let's call it an unusual plant. That's a nice way to phrase it. I also did this for Japan, and just out of curiosity, here is entire overview, including the Japanese plants, like Toyota and Nissan being extremely good. I was surprised that Nissan was so good, but Nissan also performed very well. And Toyota Tsutsumi and Takaoka plant with almost 80% value adding time, that's amazing. Mazda good, and Suzuki, Honda, Mitsubishi, Subaru, similar to kind of the German average. But yeah, the best of Toyota plants, there is nothing better in the world. But BMW comes close to the Toyota performance. Whereas the rest of Germany is not always that impressive in terms of efficiency. With this data, I was able to do analysis, because I knew not only how efficient was each line, I also knew, for example, what was the takt time, how fast was the line. And with knowing the efficiency and the takt, it's very easy to make a plot. And that one here is a plot I have on the x-axis. That is the takt time. Let's look at the left graph first. The takt time in seconds, and on the y-axis, the percentage value adding. And since it's all a little bit clustered here, I also did this with a logarithmic scale, like 10, 100,000, 10,000 seconds. And you can clearly see a faster line is more efficient. And most cars are around 60, or most lines are around 60-second takt, 60, 65, or 70, something like this. And those are much more efficient, much better performing than the slower lines. So if you want to have a good, efficient line, a faster line is usually better than a slow line. That is the general learning here. And it makes quite a difference. If you have a very slow line, you have like 30, 40% value adding time. If you have a fast line, you get to like 60%, or in case of Toyota and BMW, up to 70 and 80%, which means you need half the people to do the same work. You need half the people to assemble your car. So it's a huge difference. So I also looked at this from a different angle. And I have in this data sets both Japan and Germany. It's everything combined. It is both automotive and some commercial vehicles, some trucks and so. And I was interested, is a truck plant better or worse than a car plant? And my gut feeling was, well, trucks, more variety, and so it's not as efficient. But this very same data now with the blue dotted line for passenger cars and the orange dots for commercial vehicles, and is not much difference. My impression that commercial vehicles are not quite as good was only because they're usually working on a slower takt time. They have not a takt of a minute, but like 5 minutes or 10 minutes or so. So here too, performance is very, very similar, except of course that they have a slower takt for commercial vehicles, which makes them a little bit less efficient. But other than that, I was surprised how overlapping those lines actually are. And in the terms of statistical significance, those lines are pretty much identical. I did one more comparison, and now I looked at Japan and Germany, all plants in Germany versus all plants in Japan. And there we do have a significant difference. Again, on the left, the normal graph, on the right, the logarithmic scale. But a Japanese plant, in average, is easily 10 percentage points more efficient than a German plant. So they are better structured, they are better organized, and only a few BMW plants were able to get close to the performance of the Toyota plants. But overall, the Japan plants, the orange points, are much better than the blue dots for the German plants. So yeah, Japan puts a lot of effort in details. And whenever I'm in a Japanese plant, I'm amazed about how much attention to details they have, how much little things they change to get even half a second of improvement. And it's amazing how fast and how good they improve. Using work standards to keep the best practice and also regularly improving the work standards. Japan can do this because, especially at Toyota, they managed to have a lot of the work standard improvement cycles, their Kaizen cycles, done by the frontline operators, and maybe the first level of management, their team leader in charge of 5 operators. Whereas in the Western world, it's often the managers which own the standards, and there are much fewer managers, they have much less time, and as a result, the standards don't get improved quite as often. So yes, Japan does it a lot better than the German plants. So lots of potential. And I would assume we would have a similar graph for America or other outside of Japan countries. But I did not yet get around to do a grand tour of American automotive, but maybe in the future I'll have a chance to, but it's just so far apart in America. In Germany, my brother and I just went into a car, took our car and drove around in Germany for 1 week, visiting 20 plants. In America, we would have to fly around for 1 week and see a plant every other day, basically. Yep. But quite some impressive differences. A few more pictures of some plants. The plant with the most bridges was Porsche Zuffenhausen. Just my impression, like Munich, it was a plant which was originally, when they built it 100 years ago, it was very much outside of Stuttgart. But since then, it grew partially because Porsche is there. That helped a lot with the growth. And now it's in the middle of the town of Zuffenhausen, and lots of streets crisscrossing the plant. And they had a ton of bridges crossing the main streets and also the side streets, and they're still building new bridges. So that was one thing which I thought was very interesting, lots of bridges. Another plant I would like to talk about a little bit more is Osnabrück, Volkswagen plant Osnabrück, because it's a good plant. Performance was not bad compared to other German plants, but it lacks love. It's so unloved. It was originally a Karmann plant, and maybe some car fans of you know Karmann for being the maker of cabrios, including the famous Karmann Gia, that one here. And it's a specialist maker for cabrios, but it was having financial troubles, and at the event it went bankrupt. The plant is in the state of Niedersachsen, Lower Saxony, and Niedersachsen owns 20% of Volkswagen. So Niedersachsen convinced Volkswagen, buys this plant because we don't want our voters to get unemployed. So Volkswagen bought the plant, but it's also some kind of overflow plant. If Volkswagen runs out of capacity in their normal plants, then they send business to Osnabrück. As you may have heard in the news, Volkswagen right now does not have a problem with overcapacity. Quite the contrary, they have real difficulty filling their own plants. And as such, Osnabrück is not having much business. And the business it has is only temporary. For example, on the right, I have a graph of the station where they assembled the underbody with the car, the marriage, or in German Hochzeit. And in pretty much every car plant I've seen, it was an automatic system which kind of screwed in all the bolts automatically from below. In Osnabrück, it were a couple of people which had these screwdrivers or bolt drivers hanging from a chain and bolting every bolt by hand, kind of screwing it everything by hand, which was terribly inefficient, but it kind of made sense because who knows if that product is still there in 3 months. So you wouldn't invest $1 million to make an automated system if the whole thing will be gone in 3 months. So for the last 20, 30 years, there was a lack of funding, a lack of investment. And I still remember from the tours, the guy telling us, yeah, this chain, this brings the car body from the welding to the painting, and it's 50 years old, but it's still working. We are so proud of the change. And yeah, so it lacks love. It's a good plant, but Volkswagen doesn't really love it. And with the current discussion about closing 3 plants, that is one hot candidate for being closed. The other hot candidate for Volkswagen being closed is VW Dresden, and that is an oddball. It's a highly unusual plant. And that comes back to the history, how it started. My take of the thing is that a long time ago, 20 years or so, Daimler made the Maybach, the fanciest, most expensive, most luxurious cars they could do. And the basic Maybach was 400,000 euros, and still Daimler lost 400,000 euros with every Maybach they sold. So it was a big loss-making project. But Volkswagen said something like, hold my beer, and made the Phaeton. Also a very expensive and fancy car, also the best they could do. It lost only 40,000 euros for each car sold. Besides naming it Phaeton, the Greek god who stole daddy's car and then crashed it, It's not really a good name for a car. But to put the cherry on top, they built a car plant only for the Phaeton. And if you build a car plant, you put it far away from everywhere else, so a cheap location. But no, the Phaeton was the best, so they built it right in the middle of Dresden. Here you see the aerial pictures. That is the city center with the Frauenkirche, the famous church and the historic center. And just a few blocks away, here is the car plant, the Gläserne Manufaktur, the transparent factory, where in the middle of a park, there was a museum before. They bought very expensive real estate and made the plant there. And you see the plant on the right. Normally, you have a plant, and maybe somewhere else you have a small visitor center. For this plant, the visitor center is the center of everything, and the plant is kind of built around that. So it's all designed to impress, to show, to make it look good, but it's not very efficient. I've seen so many people, the takt was at 12 minutes, so many people were assembling a car, and they had so much time after they did their takt, they sat in the car and played with a mobile phone, because it's so inefficient. It was the most inefficient plant I've ever seen anywhere in the world in any kind of business, because it is designed to show and to impress, but not to be efficient. But it does impress, and it's a high candidate for closing. But if you still have a chance and want to see an impressive plant and get really, really close to the assembly line, it's nice to see. Just you don't want to be the one paying for the whole thing. So that summarizes my grand tour of German automotive. If you want to see any more, I have, of course, my blog post, and pretty much on every plant I have detailed blog posts on all the things I saw. Here are a couple of impressions from their entrances. But yeah, it was a great tour, and I had a great fun, and I learned a lot. So thank you very much.
Yeah, thank you, Chris, for the good presentation. And to all of you, if you've got any questions now, please use the question and answer section to post us a question. We are happy to answer as much as possible. And yeah, until then, I was able to join quite a lot of these tours as well. And interestingly, it were no tours with special invitation. It was just normal tourist tours, which everyone could book. And maybe, Chris, you could share some hints about, with only having a tourist tour available, what special tricks and features did you use to still look through the mist and see some valuable information about the efficiency of the plant and so on? Maybe you share some of your knowledge with that, please.
Most of those were tourist tours. You just sign up on their website, pay 10, 15, 20 euros, depending whatever it is, and then you join their tourist tours. And I have seen a lot of plants, so it's a lot of experience, and just compare cleanliness and organization. Are things out of place? Are the workers happy? And also a small trick about counting efficiency. If I see a worker, is the moment I see him, is he adding value or is he not adding value? Kind of walking, waiting, transport, and kind of whenever he has a hand actually on the final product, I consider it value adding. If not, then not. And with that, I made those statistics we saw earlier about percentage value adding. We're supposed to have some questions in the chat, but at the moment I can't see any questions. Yeah. I'm not sure if there's some glitch.
I have them. There's okay, one question There's one question from Dan. He's asking, is there any difference between electrical vehicle and combustion vehicle plants from the lean perspective, which you could observe?
Good question. A couple of plants assemble both electric and combustion on the same line. For example, BMW in Munich is doing both on the same line. And of course, it's very different systems, very different drivetrains, but they manage. Other plants have decided to make separate lines. For example, in Porsche in Zuffenhausen, you have the 911 line and you have the Taycan line for the electric Porsche. And it is, of course, quite a bit of difference in terms of the technology. The assembly, it's basically getting the underbody attached, and whatever's in the underbody, it's not making the underbody is different, but attaching it is not so much difference. One challenge, however, was that in German, according to the legal system, as soon as you put the battery in, you need to have everybody trained with high voltage, Hochvolttechniker in German. So everybody handling a car with batteries needs to have a high voltage certification. And another challenge was the batteries sometimes catch fire. And if they burn very well. They burn a lot. It's really hard to put them out. So, for example, Porsche and Zuffenhausen built a separate warehouse only for the batteries. So if something happens, it doesn't burn down the entire plant. So it's a lot about making it safe and having the right certifications. So do we have time for one more question?
We've got one more question, I think. Yeah, there's one thing. You were showing the difference between Japanese and German efficiencies. So there was one question from Omer. Do you think that the Germans will be able to catch up on that efficiency? And is that a second part of the question? What is the real difference? What makes it so different between Germany and Japan?
Very quickly, they can catch up. BMW
You have 20 seconds, Chris.
Yes, and it's all about attention to detail, all about really, some people ask me, what are the 3 things I have to do to become lean? It's not 3 things, it's not 3 big things, it's like 30,000 mini things to become lean. So thank you very much. And I hand over to...
Thank you very much, guys.
Thank you.
Bye-bye.
Bye-bye.
Dankeschön. Bye.
Bye.
Welcome back to the... Thank you. So